All right, problem number 1, it's saying for each problem, identify the vertex, all zeros and all increasing and decreasing intervals. So before we actually get into problem, the letter A, let's just kind of remember what each of these things means. So if I'm graphing any of these functions with squareds as your highest exponent, right, they would look something like it would be just a parabola, right? So something maybe like that, okay? It could be upside down, it might be skinnier or wider, but it's going to look like a U shape. And then we're going to look at this, and when they say vertex, they're actually talking about the turning point of the graph where it stops going down and starts going up, or if it stops going up and starts going down. Whenever it turns, that would be the vertex. Right? And then we can also talk about its zeros. So the zeros are the spots where it crosses the x-axis. We call those the x-intercepts, right? So zeros and x-intercepts are interchangeable. And then we can also talk about increasing and decreasing intervals. And so when we're talking about that, we're really trying to describe when is the graph traveling downhill and when is the graph traveling uphill, right? And that's what we mean by increasing and decreasing, right? And so we're trying to identify all of these things without looking at the graph necessarily, but that's really what we're looking for. So when they say identify the vertex, we're saying for standard form, we're going to use negative b over 2a, right? So negative b over 2a is how we find the x value of the vertex. Remember, a vertex is going to be a point in x comma y, so we're going to identify this x value by plugging in a, b, and c. So here are my a, b, and c. I'm going to use the a and b in this case. So we're going to say it looks like negative 7 over 2 times 3. So if I look at that, that's just 7 over 6, right? Positive. The negative cancels, and I get 7/6 as my x value. And then to find my y, right, I'm going to plug in this x value, this 7/6, into my equation. So let me bring up my calculator, right? And so I have my calculator here, right? And so we're just going to type this information in and find out what happens. So our problem says negative, oh, let me grab my mouse, negative, not answer, negative 3 times 7/6 squared, okay, okay, and it's minus 7 times 7 divided by 6, and minus another 6. Okay, so when you plug all this 7/6 in, you get negative 18.25 as, oh, I'm sorry, we had a positive 3x squared, so let me just go back and fix that. That's going to change my answer a little bit. All right, so I'm just going to go back up here, okay, bring it back down again, and then we're going to delete the negative. So it's positive 3, not negative 3. All right, so when I delete this, now we get negative 10.1 as my y value. So when I plugged in 7/6, I got negative 10.1. So that's what's going to go right here. And I'm done part 1. I've identified the vertex. 7 over 6, comma, negative 10.1. Right? So that's part 1. So I'm just going to just put right here, negative 10.1. Okay? So that's part 1. Identify the vertex. Okay, all of the zeros. So when I'm saying all of the zeros, I really mean the x-intercepts, and every x-intercept has a y value of 0. So I'm just going to plug in a 0 right here, okay, and say 0 equals 3x squared minus 7x minus 6. Right, and so what we're going to do with this one, this does factor. Right, in this case, I'm running a little bit out of space, so we'll just bring it right here. Okay, we're going to say this factors into, if you do your AC and your B, you're going to say 3x squared minus 9x plus 2x minus 6. So I'll let you go through and figure out where the negative 9 and the 2 came from, right? And then this is going to be 3x times x minus 3. This one's going to be plus 2 times x minus 3. And so here are my factors when I factor this expression, 3x plus 2, okay, and x minus 3, okay? And so it looks like if I solve each of these, if I set each of these equal to 0 and I solve them, I'm going to get one answer that is negative 2/3, okay, and my other answer, which is positive 3. And so if they ask what are the zeros, I would say negative 2/3 and positive 3 are the two places where the y value is 0. Okay, so we're done that. That's part 2. Okay, we want that answer. And now it says all increasing and decreasing intervals. So if I'm looking at this particular function, I'm going to say 3x squared minus 7x minus 6. If I were to, again, kind of like sketch this, here's what we know about it. We know that there's a 0 at negative 2/3, which would be about right here. Okay, and there's another one at 3, which would be somewhere way over here. All right, and we know that the the vertex is at 7/6, which is a number a little bit bigger than 1, so kind of somewhere right here, and then all the way down to about -10. Right, so this is a kind of a rough sketch of what this graph's going to look like. Okay, just using the information we've already figured out. So when they're talking about increasing and decreasing intervals, again, the way I always think about this is pretend like you're in like a little roller coaster and you're traveling down this parabola. In this case, you're traveling downhill until you get to 7/6, and then you're traveling uphill on the other side of 7/6. So I would say that this is decreasing, okay, when x is less than 7/6, okay, and I would say that this is increasing, okay, when x is greater than 7/6, okay. And another way that you might see this written is sometimes they write it as -infinity to 7/6 for decreasing, right, and they might say 7/6 to +infinity for decreasing, right? So that's, the brackets are a little different, but we're not that concerned about those, right? So this is problem letter A. I'm not going to do problem letter B because it is entirely identical. -b/2a, set it equal to 0 and solve, and find your intervals based on the graph. The only thing I will say about letter B is that the graph of this one should be upside down because you have that negative in front of x squared, so that the graph will be upside down and your increasing and your decreasing will be backwards. Okay, so watch out for those when you're doing this problem. Okay, number 2. Again, I'm only going to do letter A. It says, for each problem, identify the vertex, rewrite the following in vertex form. So again, I'm seeing standard form -b/2a. So I'm going to say -b/2a, which for us would be 20 over 2 times 2, which is 4. So I can get a 5, right? And so then my y value is going to be, again, we'll go back to the calculator, let it do the hard work. Okay, so here's my calculator again. Oop, where'd it go? Calculator. Okay, and we're going to plug in our information. So into our formula, let me see if I can move my calculator to a better spot. Okay, move this one over a little bit. Okay, so it's not in our way. All right, so let's try this again. So now I'm going to go to my calculator and I'm going to type in or plug in a 5, and I'm going to say 2 times 5 squared, okay, minus 20 times 5, okay, plus 53. And so when I plug in a 5 into this function, it looks like I get back a 3, right? So we get a kind of a nice number back. So I'm going to say that my y value is 3, okay? And that means that my vertex is the point 5, 3. And so now it's saying rewrite the following in vertex form. So to remind you, I'm going to use this space over here to just remind you what vertex form is. Vertex form is a times x minus h plus k, where this vertex that we just found is an h and a k. Okay? So when I'm rewriting this in vertex form, I'm just going to say y equals, well, a is the a value, which for us was the 2. So 2 times x minus 5 plus 3, right? And I would say this is vertex form of this original f of x function, right? So again, second problem, letter B, same idea. Okay? Now it's saying use vertex form from number 2. So we're going to use what I just did right here for letter A. It says write a function that is a transformation of this function. It says up down 2 units. So we're going to focus on down 2 units. That's a typo. Okay, and to the left 5 units. So if I'm saying down 2 units, that means that my d value is going to decrease by 2 units. So we're going to say 2 times, okay, y equals 2 times. We're going to leave this blank because we don't know what that is yet. But this is down 2 units means that we decrease this by 2. So it's going to become plus 1. And to the left by 5 units means that if this is -5, I'm going to go more negative 5 units, right? So instead of this being 5, I'm going to subtract 5, right? And it's going to become 0. I'm sorry, 10, right? So I'm going to say x minus 10. Okay, so I decreased this 5 more, and it became x minus 10. Right, so same idea where you're just going to change your h and your k using this information, and that will be your final answer. Okay, so let's move on to the next group of problems, okay, and talk about polynomial functions. So it says write the following polynomial functions as a product of linear factors. Again, these are both 4-term polynomials, so I shouldn't have to do both of them. Okay, in this first case, I'm just going to take out the common x squared. So I see an x squared in all of them. And this looks like now x cubed plus 5x squared minus 9x minus 45. Okay? And so now I'm going to focus on this inside function and say, this can be now factored using the grouping method. So I'm going to group these, okay, and I'm going to say this first group has an x squared in common, okay, and that leaves me with x plus 5. And this second group has a negative 9 in common, and I'm going to also leave behind an x minus 5. I'm sorry, an x plus 5, okay? And then this x squared was sitting out front the whole time. So now I'm going to regroup this inside. The x squared and the minus 9 go together. X squared minus 9 is a factor. X plus 5 is also a factor. And then this x squared is sitting out front. But this says linear factors. Okay? Linear factors means I can't have squareds, right? And so I'm going to actually break up this x squared minus 9 again. This does continue to factor. So I'm going to say x times x, that's x squared right here. X squared minus 9 is x plus 3 and x minus 3. Okay? And x plus 5, right? So I'm saying as a product of linear factors, there's no more squareds in my problem. I broke up everything as much as I can. This would be the answer to the first part, product of linear factors. Okay, the second part says find all of the zeros. What that means is set each one of these expressions equal to 0. So I'm going to say each of these x's, when I set those equal to 0, will give me an answer of 0. When I set x plus 3 equal to 0, I will get negative 3. Okay. When I set this equal to 0, I will get positive 3. And when I set this equal to 0, I will get negative 5. So I would say these 4 answers are the zeros of letter A's function. Okay? And again, letter B will work the same. You just have to make sure you factor and factor again. Okay? Problem number 6. It says write the polynomial function of least degree in factored form. And so here's what you need to remember about this. Okay? We need to talk about the end behavior of the function. So I'm going to start off with that. I'm going to say this is down on the left and up on the right, which we write just down and up. Okay? I'm going to also identify the zeros of the function. So I see a 0 right here. It looks like at negative 3. So I'm going to say x equals negative 3 is a 0, and another one right here at x equals 4. Okay? Now I need to look at those zeros and say, how is the graph behaving at those zeros? And so at negative 3, it looks like it turned like a parabola. And so if you remember, we said that means that this has a multiplicity of 2. Okay? And it went right through 4, and so I'm going to actually say that this has a multiplicity of 1. It traveled straight through like a line, and so I'm going to leave that one alone. Okay, so I'm going to write each of these functions now as factors. Right? If x equals negative 3 is a solution, is a 0, I can set this now equal to 0 and say x plus 3 equals 0. That means that x plus 3 was a factor. So I'm going to write x plus 3 as a factor, and I'm going to do the same thing with the 4 and say x minus 4 is a factor. Okay, and then I'm going to look at the multiplicity and say, because this is multiplicity of 2, the x plus 3 is going to be squared. Okay, I'm going to look at this and say, okay, down up means that the leading coefficient was positive, which means I don't need to put anything in front of this function. I'm just going to say y equals, and I'm done. And that would be the function of least degree in factored form. I don't need to multiply all that out. I'm going to leave it go. So I am going to do this second one because it's a little bit different. Okay, so let me get rid of this. All right, and so we're going to do the same thing. I'm going to look at this and say it's down, down as my end behavior. So let's start by identifying that. I have a 0 at x equals negative 2. I have another 0 at 1. And it looks like I have a third 0 at 5. So now let's identify our multiplicity. So if I'm going through negative 2, it's a multiplicity of 1. Goes straight through. Okay. When I'm talking about positive 1, this has a multiplicity of 3, and that's because it travels turning and turning again, and so that indicates a cubic function. And then when I look at 5, I'm seeing it turning like a parabola, so this one has a multiplicity of 2. Okay, so now I'm going to put my factors together. So again, x equals negative 2 means that I had a factor of x plus 2. X equals 1 means I had a factor of x minus 1, and x equals 5 means an x minus 5. And now I need to add in my exponents. A multiplicity of 3 means that this one will be cubed, and a multiplicity of 2 means this one will be squared. And because my end behavior was down, down, this indicates negative end behavior. Oop, let me get rid of all that extra. Okay, let's try that again. My computer's acting funny. Negative, okay, without the extra line. All right, so negative means that, down, down means that I had an even and negative leading coefficient, and so I am going to put a negative out front of this and say my function now is y equals. I had to put that negative there because I was going down, down. If it was going up, up, I would be positive, right? So you have to look back at how n behavior indicates positive versus negative and even versus odd. So that's something else to look out for. Okay, so let's move on to the next group of problems. Okay, it says there's a function that has zeros at 2, 0 with a multiplicity of 2 and negative 7 and has a negative leading coefficient. Sketch a graph that could represent this function, and then in part B we're going to write a polynomial that could produce those zeros. So on my graph right here, let me make it a little bit larger. I think I can. No, I can't. Okay, so I'll leave it. So I'm going to say x equals 2, okay, x equals 0, and x equals negative 7, which is way over here. Okay, so I just put down points on there. I know the graph is going to travel through these points. Negative leading coefficient. Right, so that means that my options are either down, down, or up, down, because those are my my negative leading coefficient n behaviors. So I need to figure out, is this an even function, which means down, down, or is it an odd function, which means up, down? Right. So when I look at my zeros, I see 1 0, 2, 3, 4 total zeros. 4 total zeros makes this an even function. So I counted this as 1, 2, 3, 4. So an even function means down, down. Even and negative means down, down. Okay, so that means that I know my graph's going to come out of here and travel down, and I know all the way on the right it's also going to travel down. So now I need to say, okay, it's going to go up, and then I need to turn around and eventually get back down so it can go through this 0. So I'm going to turn it. I don't know where it's going to turn, so we'll just say something like that. And so now I need to think about how's it going to act at 0. Because it has a multiplicity of 2, it's going to act like a parabola, and it's going to turn around and go back up. And then it's going to eventually go back down. So again, your peaks might be a little bit different, but you do need to have it go straight through 2 and straight through negative 7 because they are multiplicity 1s, and you need to have it bounce off of 0 because it has a multiplicity of 2. So my sketch would look something like this. Again, it might be a little bit higher or a little bit lower on your turns, but around the points should act like that, and it should definitely be traveling down, down. Okay, so writing a polynomial that could produce these zeros, again, the idea is that I'm just going to say if I have a 0 at x equals 2, I had a factor at x minus 2. Right, if I had x equals 0 with a multiplicity of 2, I have x with an exponent of 2, and x equals negative 7 means that x plus 7 was a 0. Negative leading coefficient just means put a minus sign in front of this. Okay, and I'm going to say y equals this function. Again, it's okay to leave it in factored form. You do not have to multiply out all of those expressions. Okay, so here's the last problem that we'll do in this video. We'll stop at problem number 8, right, and it's asking about average rate of change using this graph. Right, and so just to remind you about what average rate of change is, essentially average rate of change is slope. Right, this whole y2 minus y1 over x2 minus x1. Oh, I missed the minus sign. Okay. x2 minus x1. So this is slope for lines, but we're just going to generalize it and say between any 2 points on the graph. So when they say on the interval from 0 to 1, they're saying that they want you to use 0 and 1 as the x's. So let's check the interval from 0, x equals 0 to x equals 1. So I'm going to plug on the bottom, I'm going to say 1 minus 0. That would be x2 minus x1. I need to go over here and look at my graph and figure out what is the y value that goes with x equals 1. And I'm seeing in this case it's this point right here, 1 comma 1. So when x is 1, y is also 1. And when x is 0, y is also 0. And so I would say this is 1 over 1, which is equal to 1. So I'm going to say from 0 to 1, this is the way we write this, from 0 to 1, the interval in this case is, or the rate of change, the average rate of change is a 1. Okay, from 1 to 2, we're going to do the same thing. I'm going to say now this is going to look like a 2 minus 1 on the bottom. Oh, which you can't see. Let me slide down a little bit. Okay, so 2 minus 1. Okay, and then I'm going to go over here and say at 2, my output is 4. Okay, and we already said at 1, the output is 1. Right, and so in this case, I'm going to say my average rate of change is 3 over 1, which is 3. Right, and so on the interval from 1 to 2, okay, the average rate of change was 3. So now it says which one has the higher average rate of change. I'm going to say in this case, it looks like the interval from 1 to 2 has the higher average rate of change.